Dear students, welcome to the next lecture on the solar energy. And in this lecture, we will learn about the photovoltaic cells, which is used for the conversion of solar energy directly into the electricity, that is the usable form of energy. Let us start with the photovoltaic cells. If you like my lectures, then please share and subscribe. The solar cells are those which converts solar energy into electric energy. These are also called photovoltaic cells or PV cells as they have voltage producing capacity. Therefore, we can describe photovoltaic cells as semiconductor devices which converts sunlight into electric energy. The voltage of the cell is directly proportional to the sunlight incident upon it. The PV cell works on the principle of photoelectric effect. So, what is the principle of the PV cell? As I have said, that it is based on the principle of photoelectric effect. That is, the sunlight, which consists of electromagnetic radiations, and these radiations have particles. The particles are called photons. Each particle carries energy equals to h nu, where h is the Planck's constant and nu is the frequency. Thus, we can say that E is equal to h c by lambda, because nu is equal to c by lambda, where c is the velocity of the light and lambda is the wavelength of the radiation. So, how to construct a PV cell? A solar cell is like a diode consisting of a P-N junction. A typical solar cell is like a thin wafer. Wafer biscuits you might have seen, which have many layers. Similarly, this thin vapor consists of an ultra thin layer of N-type silicon, that is phosphorus doped silicon, below which is a thin layer of boron doped P-type silicon. The junction between the two layers is called the P-N junction. It has two electrical contacts, one as a metallic grid and other as a layer of coat of noble metal, normally silver, at the back of the P-type silicon. When the sunlight falls on the grid, it allows the light to fall on the semiconductor between the grid lines, which has an anti-reflecting layer that increases the amount of light to be transmitted to the semiconductor. So, how the PV cell works? When the light radiations falls on the PN junction, that is the diode, the holes and electrons are generated. Holes are positively charged and the electrons are, we all know, they are negatively charged as a result of absorption of the radiations. The electrons move and collect at N-type ends because it is positively charged, whereas the holes moves and collects to the P-type ends, which is negatively charged. When these two N-type and P-type are connected using a external wire, then there is a flow of current through the external circuit. The electricity which is generated is called photoelectric current. Let me describe the phenomenon using this figure. Here you can see there are two layers. The upper layer is the N-type silicon, the lower layer is P-type silicon, and in between is the P-N junction. When the holes and the electrons are generated as a result of the light energy coming to the P-N junction, the holes start moving towards the P-type and the electrons move towards the N-type. And when it is connected with an external wire, the electrons start moving in the external circuit, generating the electricity. You can also see that at the back of the P-type silicon is the silver coating, and the anti-reflecting coating in between the grid lines is also shown in the figure. So this is how the solar cell works. We can draw the conclusion that each photovoltaic cell can produce around 0.5 to 0.6 volts regardless of its size. That means the current, the voltage which is produced does not depend upon the size of the cell. The bigger the size or the smaller the size does not produce any difference in the production of the voltage. The same voltage is produced by the cell. The current which is produced is proportional to the intensity of the sunlight striking the surface of the cell. Solar cells are therefore connected in series to produce higher voltages. Namaste. We'll learn more about it in my next video. Till then, share and subscribe. Thank you.